Hi everyone. Today we're going to be working through the first day of section 7.3, and we're going to be working with similarity still, but now we're going to be working specifically with triangles. And what we're going to be doing today is learning about some shortcuts to determine if a pair of triangles are similar. And so this is going to have a lot of parallels to when we did triangle congruence. If you think back, when we started talking about triangles, or congruent triangles, we said that in order to be congruent, they had to have all angles congruent and all sides congruent. And so we started with that, but then we learned some shortcuts to prove that triangles were congruent. So we're going to do the same thing today. In our video yesterday, we said that in order for two triangles to be similar, all the corresponding angles had to be congruent and all corresponding sides had to be proportional. So we had to check all 6 of those parts, but today we're going to learn shortcuts for proving that two triangles are similar. So our first shortcut that we're going to have is angle-angle similarity. And what this says is that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So this is actually a whole lot less work. If we can look at two triangles, for example here, and we know that angle A is congruent to D, angle B is congruent to E, then right away we can say those two triangles are similar. So I'm going to write our similarity statement. We can say triangle ABC, use our symbol for similarity, and then we just want to make sure we do our vertices in the same order. So if I went ABC, we would finish that off with triangle DEF. So that's angle-angle. Okay, the next one we have is side-side-side similarity. And what this says is if the 3 sides of one triangle are proportional to the 3 corresponding sides of another triangle, then the triangles are similar. So now here we actually don't consider the angles at all. We just work with the corresponding sides. So in other words, if we can compare, we check all 3 pairs of corresponding sides and they have the same ratio, then we know those triangles are similar. So we could say triangle ABC is similar to triangle DEF. Now, of course, if this were a problem, all the side lengths would be given to us and we'd have to check that these have the same ratio, same similarity ratio. Okay, and then the last one for similarity, so we actually have fewer than we did for congruence. Here we only have 3 for similarity, is going to be side-angle-side similarity. So this says that if 2 sides of one triangle are proportional to 2 sides of another triangle, and their included angles are congruent, then the triangles are similar. So in other words here, if I knew that AB and DE were in the same ratio of BC and EF, and I know that angle B is congruent to angle E. Again, it has to be the angle that's trapped in between those 2 sides. Then I could say those triangles are similar. So now what we're going to do is just look through some examples and make sure we can determine whether or not the triangles are similar. Okay, so that's what our 2 goals are for today. First, to determine whether triangles are similar using either AA, SSS, or SAS, and then to be able to write a similarity statement. Okay, so here's the first one. So I need to look at these triangles, and first I'm going to decide whether or not they're similar. And so if I just look quickly, it looks like they're not going to be. However, we need to be careful here. If this is a 90-degree angle, I know that the 2 acute angles have to add up to 90. So if this is 61, then I know my other acute angle is going to be 29. So now I can see that I've got angle G is congruent to angle L, and angle F is congruent to angle J. So there, by AA similarity, angle-angle, I can say that triangle HGF is similar to triangle. Well, H is going to correspond to K, G corresponds to L, and then F corresponds to J. And again, that was because angle F and J are congruent, and then G and L are going to be congruent. Okay, the next one for number 2. Now, if I look quickly, I can tell I'm looking to see if I have side angle side, because that's the information that I'm given here. So right away I can tell my included angles here, the angle that's trapped between those two sides, the included angles are congruent. So now I need to check if AC, the ratio of AC to DF, I need to know, is that the same as the ratio of BC to EF? So let's see, AC is 3, DF is 5, BC is 6, and EF is 10. Well, if I reduce my second ratio, I can divide top and bottom by 2, so I'm going to get 3/5. So I know those corresponding sides are proportional, their included angles congruent, so these are similar by SAS similarity. Make sure you don't just put SAS without that symbol, you have to have that similarity symbol. And then I can say that triangle ABC is similar to triangle DEF. And I guess I should have been going back. Those were similar. The number 1 was similar as well. All right, let's keep going. So for number 3, if I'm looking at this triangle, I don't have any information about sides, so I know this can't be SSS and it can't be SAS. So really the question I have, the only one left is this is similar by angle angle. So if I look here, I notice quickly that vertical angles are going to be congruent. So I'm just going to make a note there. So I've got one pair of angles because of my vertical angles. Then what I notice here is I have parallel lines. So I'm going to extend these out. So this is parallel to this. So if I consider this PT and SR are my parallel lines, and I can consider that TS is a transversal, then I know this angle here is congruent to this angle because those are alternate interior angles, right? So we know back from chapter 3 that I have if parallel lines, then alternate interior angles are congruent. Now, you wouldn't have to write that out on a test, but I just want to make sure everyone knows why those are congruent. So now I've got 2 pairs of congruent angles, so I can say those are similar by angle-angle similarity. And now here's where we're going to have to be really careful about our statement. So let's see, I'm going to do triangle. I'm going to call it PTQ. And I know that triangle is congruent. Well, that corresponds to R, so I just don't have any markings. T is going to correspond to S, and then I have Q. So triangle PTQ is similar to triangle RSQ. Now, obviously keep in mind, I could have said, I could have started, let's say, at Q. I could have said QPT is similar to triangle QRS. Again, as long as the order, the correspondence is correct, it does not matter what the actual order is. Okay, so let's see. Last one here. What we have to realize here is that I have 2 triangles. These are overlapping, so this one's a little trickier. So I actually am comparing triangle AXY to triangle ABC. And I know I have these side lengths, 20 and 25. Then AB is actually 45. And then I know this is going to be 55. Let me move that over so you can see it. So again, my choices I know are angle, angle, SSS. Let me just write this here. So it's either angle, angle, SSS, or SAS. Now, looking at this triangle, I know it's not going to be SSS because I don't know anything about those third side lengths. Let's see, angle, angle. Well, I do know one pair of congruent angles. I know this angle A has to be congruent to itself, right? That's the reflexive property. So angle A is congruent to angle A by the reflexive property. So I have one pair of congruent angles. Gosh, there we go. Let's keep it here. I have one pair, but there's no way I can come up with another because I don't know that these are parallel sides. So it can't be AA, so I'm going to check SAS because I have an included angle and two sides. So now I need to check if the ratio of XA to BA is equal to YA over CA. And if that's true, then I'm going to have to say yes. So let's see, XA is 20, BA is 45, and then on the other side, YA is 25, CA is 55. So I need to do some reducing. You could do this in your head, or again, you always have that nice N over D key, and if you type this in, it's going to give it to you reduced. So what I end up is 4/9, and then if I do 25 over 55, I end up with 5 over 11. Since those ratios are obviously not the same, these triangles are not similar. All right, so we're going to go on to the next page here and do a couple more. All right, let's see what we've got here. So again, I know I have 3 to choose from, SSS, SAS, and AA. Again, we're going to rule out SSS right away because I don't have those third side lengths. I can get one pair of congruent angles because of my vertical angles. But since I don't know if these sides are parallel, I can't go after angle, angle. So we're going to try for SAS and see if that works out. So now, when I'm comparing the sides, I'm going to compare the shorter side here, TX, to the shorter side over here, XV, and I want to know if that ratio is the same as the longer of the two sides on this triangle, UX, and the longer one here, which is XW. So let's see, TX is 12, XV is 16, UX is 15, and XW is 20. So here I'm going to divide by 4, so I'm going to get 3/4. Here I can divide by 5, I get 3/4 as well. Since those are proportional, these two triangles are going to be similar by SAS similarity. And let's see, I know that triangle, I'm going to start with T, so TXU, I'm going to travel along that short side first, is going to be similar to triangle VXW. All right, one more to go. All right, so if I look at number 6, the only possible way I could prove these similar would have to be by SSS because I don't know anything else about the angles of these triangles. So I'm going to compare the sides. So I know these shorter sides must correspond to the shorter sides on this triangle, and the longer one would have to be proportional to the longer side here. So I'm checking PQ, and I want to check that compared to RS, and then QR, let's see, to RP, and then we'll check the relationship between PR and PS. So I have 4 over 6. QR is also 4. RP is 6. And then PR is 6. PS is 9. So if I reduce these, I get 2/3 is equal to 2/3. I can divide by 3, and I get 2/3 as well. So since those are proportional, I have side, side, side similarity, and I can do triangle PQR is similar to triangle, say, SRP. Now, because these two sides are congruent, the order isn't going to be so important as long as my segment PR here corresponds to this SP. So that's what we're going to be working with. Again, this is just day 1 of this section, so tomorrow in class we'll be working through a sort to make sure we can determine if triangles are similar, and then as we go on with this section we'll be using similarity to solve problems.